All right, everybody, let's get rolling on our 10.2 homework. I'm going to do 6 problems with you guys here out of the 21, I think, that I assigned for you right here. So first thing to note, even though this worksheet says 11.2, that's from an old book. This is actually going along with 10.2 in our Pearson book, areas of trapezoids and rhombuses and kites. So let's get rolling here. We're going to find the area of the trapezoid given to us here in problem number 1. So remember, guys, we really want to stress here the importance of this 3-step method. Step number 1, write out the formula. We are looking for area of a trapezoid. So that formula right here, area of a trapezoid, is a tricky one. That's 1/2 multiplied by the height of your trapezoid, and then multiplied by the sum of your two bases, base 1 plus base 2. And, in case we forgot, the bases of the trapezoid are always the two sides that are parallel to each other. Now, normally, those are located on the top and the bottom of the figure, but not always. And in this case, they are. This side right up here has a length of 12, so that's one of your bases. This side down here that's parallel to it is 6. And just like we've been talking about with parallelograms and triangles earlier on in this chapter, the important thing here is that the height of a figure always has to be measured perpendicular to the base. So let's just say, for the sake of argument, they told you that this side over here had a length of 11. That would not be the height of that figure, because the 11 does not make a right angle with the 12 or the 6 on the top or the bottom. It's the 10 right here, everybody, that is perpendicular to that base, which also makes it perpendicular to this base right down here. So forget about that piece. That 10 right there is your height. So this is a pretty straightforward problem, as you'd usually expect at the beginning of a worksheet, where they gave you everything that you needed and they didn't give you any extra information. So step 1, write down your formula. Step 2, fill in what you know. We don't know the area, that's what we're trying to find, and now that equals 1/2 times the height of our trapezoid, again, is the perpendicular distance between your two bases. That's a 10. I like to put that in parentheses, and now another set of parentheses. The bases are the parallel sides. So we've got a 12 on the top, and we're going to add that to a 6 on the bottom. So that's step 2. Fill in everything you know, and you'll notice we were able to come up with the value of h, base 1, and base 2. So the only unknown we have right now is a, the area itself, and that means, everybody, that there's no reason we couldn't just go to our calculators right now and type in all of this together all at the same time. So in fact, I'm going to do that with you guys. If I can remember where I put my calculator here, let's go with this one. All right, now remember, your calculators are programmed with how to do order of operations, so let's go with it. The 1/2 is probably best put in as a 0.5. We're going to multiply that by our height, which was 10, and then in parentheses, our two bases here were 12 and 6 added together here. And when I hit enter, I ended up with 90 for the area of that particular trapezoid. So that is going to be a 90 right there. There were no units given to us in this problem, so when that happens, we like to just put a generic U for units and square that. So 90 square units, everybody, is our answer for number 1. Okay, 2 and 3 are pretty similar to that. When we move on to number 4, they ask you to find the area of the rhombus or the kite. Now, lucky for us, we don't really have to spend much time thinking about which one of those we're dealing with here, because the formula is the same for both of them. So now in this case, because we have congruent sides, I should say 2 pairs of congruent sides that are next to each other, adjacent. This one here, those two sides are congruent, and then 2 sides here are congruent next to each other as well. This is a kite. But as I said, the formula is the same either way. Formula for either of them is 1/2 multiplied by diagonal number 1 times diagonal number 2. Much easier formula than we came up with just a second ago. And a problem like this always confuses people a little bit when they see it first, because the information is presented to you in kind of a weird way, but this is actually very straightforward here. Let's see what we've got. So we need 1/2 and then the length of each one of our two diagonals. Well, let me switch colors on you and highlight this. One of the diagonals goes from, let's say, the vertex up here on top down to the opposite vertex straight across from it. So this line in blue right here is going to be diagonal 1. Well, they gave you that measurement right out here. That diagonal there has a length of 13. So I'm going to go ahead and put that in for D1. And now let me switch to red on you here. The other diagonal goes from this vertex on the left to this vertex on the right. So this whole piece in red is diagonal number 2, and they gave you that measurement as well, which is 24. Okay, so again, just like problem number 1 that we did a moment ago, they gave you every piece of information that you needed right here, and all we have to do is put that entire right side into our calculator all at once. Now, actually, doing this one by hand isn't that hard. Remember that when you're multiplying 3 numbers, the order doesn't matter. So in my head, I'm going to multiply 1/2 by the even number here. Half of 24 is going to be 12, and 12 times that 13, let's see, 12 times 12 is 144. Add another 12 to that, we are going to get 156 for the area of that figure. Again, no units were given to us, so we just put a generic U for units, and we square that. So 156 square units is our answer for number 4. Now, in number 10, we like at this level, guys, to mix things up on you a little bit and to ask you to see if you can find some missing pieces. So what they've done here is they've given you this length here from there to there. It's not terribly well labeled. That's what they're calling X, and we're supposed to come up with that. The 15, I'm pretty certain, is supposed to be this measurement right over here. All right. Now, in a problem like this, they've given you the area. So this is different from what we were doing in the last 2 problems, but they've asked you now to come up with the value of X. And this is where the 3-step method is really important, guys. If we start with the formula, that kind of provides us a roadmap. Now, by the way, looking at the figure, I see 1, 2, 3, 4 congruent sides. That automatically makes this figure a rhombus. So they didn't tell you that, but you had to deduce that on your own from the diagram. And the formula for area of a rhombus is the same as the formula we just used for the area of a kite. 1/2 diagonal 1 times diagonal 2. So there's your formula. And now for step 2, we're going to fill in what we know. And this time, they told you that the area of the rhombus was 330 square inches. So that goes here on the left, because the area for the first time here is something that's known. On the right-hand side, we've got a 1/2. Now, here's where things can get just a little bit tricky. Diagonal number 1, a lot of people want to put a 15 in for that, and you've got to be careful. The 15 represents the distance from here to here, but we've got this other component to it as well. Well, to go all the way back to chapter 6, we need to remember that a rhombus is also a parallelogram, and in every parallelogram, the diagonals bisect each other. That means that this point of intersection in the middle is the midpoint of both of the 2 diagonals. So if this was a 15 in the lower left, then we've got a 15 here in the upper right as well, and that makes the entire first diagonal have a length of 30. Which I got by multiplying those by adding those 2 diagonals together. The second diagonal now from here to here, let me do that in green, is X. That means that this piece right over here has a length of X as well. And when we add up the 1X plus the other X, we are going to get 2X now for the measure of that second diagonal. All right, so that is what step 2 is going to look like here, guys. We've gone ahead, we filled in everything that we know, and now step 3 is to go ahead and either evaluate or solve. Now, in the last couple problems, when the variable we were looking for was the unknown on the left-hand side and everything on the right was known, we were just evaluating. We were just putting all of that into our calculator at once. But here, when the variable is embedded within the right side of that equation, this is more solving. So the first thing I would do is try to see if there's anything we can do to simplify this right-hand side. So the left side is just going to stay 330 for now, and the first thing I notice, guys, is that 1/2 of 2 is just 1. So 30 times x times 1 is just going to give us 30x. And then from there, the only thing being done to x is that it's being multiplied by 30. So we're going to divide both sides by 30 here. Zeros cancel out, and the 33 divided by 3, those cancel too, sorry, is going to tell us that x is equal to 11. Now in this problem, they told us the units were dealing with inches right here. You don't need to put inches in your answer because they've already included inches on the x right there. We were just coming up with the numerical value of x, so that's going to be 11. All right. This is another problem, number 13 here, that kind of weirds people out a little bit because they go, wait a minute, we've never done anything like that. And then you kind of show them how to do a problem and they go, oh, yeah, that's really not that bad. This is really, you guys, the same problem that I just worked out with you here in number 4. Okay, probably a different answer, but they gave you a kite here and they told you the lengths of the two diagonals, 13 for the vertical diagonal and 24 for the horizontal diagonal. The exact same thing is going to happen here. Let's talk about how that's going to work. Okay, so step 1, we are dealing with a kite, and the formula for area of a kite is 1/2 times diagonal 1 times diagonal 2. Okay, step 2, fill in what you know. Now again, look at the directions. That gives you a clue. Find the area of the figure. That means we're supposed to come up with A, meaning we don't know what the area is. So it's okay just to leave that as a variable. But we better know the value of both of our two diagonals. Otherwise, we're not going to be able to solve this problem. So let's switch to blue here, and one of the diagonals, doesn't matter which one you do first, let's talk about the horizontal diagonal. Now the horizontal diagonal starts right here, what I'll call point A, and ends over here at point B. Guys, all you got to do is count your way over from A to B. So starting at A, we go 1, 2, 3, 4, 5. Took us 6 units to get to B here. So now I know that this distance from here to here has a length of 6. So that is the length of one of your two diagonals. The other diagonal, let's switch to red right here. I'm going to call this point up here C, this point down here D, and to get from C to D, we just count our way down. 1, 2, 3, and 4. So that second diagonal is going to have a length of 4. And now that we know the length of both D1 and D2, the variables on the left isolated and the right side is all constants, all we have to do is evaluate that. With this one, in my head, I'd probably do 6 times 4, which is 24, and then take half of that number, which is going to get us 12. No units were given to us here, so we'll just put generically square units. Okay, so 12 square units is our answer for number 13. All right, let's move on to 16 here, finding the area of a polygon where a little bit of extra information is given, but also not all of the needed information is given to you. You're going to have to hunt for it a little bit, so this is quite a bit harder than the first problem that we did. Okay, guys, so step 1, start with what you know. We see one pair of parallel sides here, the 9 on top and the 19 on bottom, so that makes this figure a trapezoid. And the formula for area of a trapezoid, this is the tricky one here, 1/2 times your height times the sum of base 1 plus base 2. So we need to know the measures of H, B1, and B2 in order to be able to pull this off. All right, let's go to step 2. Again, look at your directions. Find the area of the polygon. We don't know A. We're not supposed to know A just yet, so that's your unknown. But on the right side, we better be able to fill in these 3 things. So we've got a 1/2. We do not know our height yet, and then the sum of our two bases. Actually, let's start with the easy part. The bases, I'll do that in blue. The bases are the parallel sides. So one of these pieces up on top has a length of 9. The other one, got to be just a little bit careful here, is this entire bottom side right here. Now, if you look at how they centered the numbers, it really looks to me like that 8 is just the bottom side of that little right triangle, and the 19 is that side right over there. So we're going to have to put those two together here and add the 8 and the 19 together, and that is going to get us a total of 27. So it's 27 that's the measure of the second base within that figure. Okay, that wasn't too bad, but the hard part of this figure is coming up with the height. And 17 is not the height because it's not perpendicular to the base. That is not a right angle there between the 17 and the 8. The right angle occurs right here, which means that this piece right here, and the word for that is altitude, everybody, that altitude is actually the height of our trapezoid. And we need to figure out the measure of H because it was not given to us. Well, to do that, we're going to focus on this right triangle that's given to us right here within the figure and realize that within that right triangle, we know 2 of the 3 side lengths. That means that the Pythagorean theorem can be used to find the third. Leg squared plus leg squared equals hypotenuse squared. So let's run with this. One of our legs is H, so we'll write H squared plus the other leg is 8. we're going to square that, equals our hypotenuse, which is 17, and we're going to square that as well. Let's fill in what we know. H squared plus 64 is equal to, and 17 squared is 289. We're going to subtract that 64 from both sides and get h squared is equal to 225. And we undo a square by taking the square root of both sides of the equation here. The square and the square root cancel, and we get h is equal to 15. Now, it would have been really, really cool if you guys had learned some of those Pythagorean triples that we talked about. It was kind of like an optional part of the notes from 8.1. 8, 15, 17 is I believe, the fourth of the 5 Pythagorean triples that I asked you guys to kind of pay attention to. If you recognize that, you could have looked at this figure straight away and gone, oh, there's a leg of 8 and a hypotenuse of 17, then the missing leg automatically has to be 15, and you could have skipped all of this work right here. Either way you get there, doesn't really matter. We know that the height of this figure is now 15. All right, so with that in mind, let me get rid of that big X that I drew. It's not like that work wasn't correct, so we still want to see that there. Now, the entire right-hand side of this figure is known. It's all filled in. So this is another spot where we can just go to the calculator here for step 3 and type in everything in one step over there on that right side. So I'll do that with you guys. So we're going to 1/2. All right, so again, I'm going to put in a 0.5 multiplied by our height, which was a 15, and then in parentheses, our two bases added together were a 9, added to, I believe, a 27. Let me double check that. 1/2, 15, 9, and 27. Yep, that's it. And if we type all of that in together, we get our final answer here of 270. All right, so the area here is 270. No units were provided, so we're just going to put square units. And that's the answer to number 16. All right, so they're going to make you dig for some of these, everybody. This is not middle school math where the information you need is always just presented to you. You're going to have to find some of it on your own. And the last problem I want to do with you guys here is problem number 20. As I'm looking at it here, guys, the last 3 problems here, 19, 20, and 21, are all going to require you guys to do a little bit of work here to get what you need. So this is similar to the problem we just did, but even tougher in that regard, because you've got this weird 50-degree angle here, so we'll talk about that in just a second. Okay, first step, write down a formula. What are we dealing with? Again, just like the last problem here that we did, number 16, I see one pair of parallel sides. That makes this a trapezoid. So the formula for area of a trapezoid is still going to be 1/2 times height, that's an ugly h, times base 1 plus base 2. Okay, fill in what you know here. Step number 2, and again, guys, the directions are still find the area, so we don't know A, we've got to find it there, is equal to a 1/2. The height of this figure is something we need, and so are the two bases added together. So let's see what we know. We've always said here, guys, that height is the perpendicular distance between your two bases. So if we've got a parallel side here and here, the height would be the side perpendicular to those. Well, here's your right angle right there, and that means that this altitude right over here, 21, that's the height of this figure. It won't always be given directly to you, but it was in this case. Okay, let me switch to blue now for my bases. The bases are the two parallel sides, and there's one piece right up here that has a length of 11. That was the easy part. The second base is going to be tougher. The second base is the entire bottom side that goes from here to here. So I'm going to write base 2 there, and we've got to try to figure out how long that is. Okay, in order to do that, we're going to have to do a little trick right here. From this point, we're going to drop an altitude straight down to the bottom and form a right angle. Now, I'm going to ask you guys to guess how long that blue line segment was that I just drew. Well, you might notice we have formed a rectangle over here on the left-hand side, and if that vertical piece of the rectangle is 21, so is this piece right over here. All right, so we've got a 21 there. And if I asked you how long this horizontal piece was, well, that's going to be the same as this. Remember that opposite sides in a rectangle have to be congruent. So I know that base 2 is made up of this 11 right here, but we also need to know this length right here. And we're going to have to add that to the 11 to get base 2. So to do that, we've got a right triangle that's located right here, everybody, and we've got to do a little bit of digging on that. So let me take a second down here and redraw that right triangle maybe a little bit bigger. And what do we know? Here's your right angle. We've got a 50-degree angle here. We've got a 21 over on this side. And we're trying to come up with the length of that bottom piece right there, which I'm going to call X. So let's switch to green right here so we can keep our work separate and see what we can do. All right, unlike the last problem, the Pythagorean theorem does not help us here because we only know the measure of one side. So when you only have one side, but you do have an acute angle measure, we're going to do some basic trig here, sine, cosine, and tangent. So we're going to focus on that 50-degree angle and pretend that we are standing right there. The 21 is all the way across the figure from us. That's the opposite leg. The x is right next to us. That is the adjacent leg. And the trig ratio that uses opposite leg and adjacent leg, think SOHCAHTOA, is tangent. So we're going to write tangent of 50 degrees equals opposite leg of 21 over adjacent leg of x. Not our favorite setup here, guys. The x is on the bottom of that fraction, so we're going to flip the left side with the bottom of the right. And we're going to get x is equal to a 21 divided by the tangent of 50 degrees. And that we should be able just to dump into our calculator and get the answer right off there. And so let's try that again. 21 divided by the tangent of 50 degrees gets us 17.62 for that answer here. 17.62. Now, you got to be careful here. What we have found is the value of x right over here, which was this piece. 17.62. But that's just one of the components that makes up what we really needed right here, which was base 2. So base 2 is going to be the sum. Well, I'm running out of colors here. Base 2 is going to be the sum of this 11 and that's 17.62. So let me go back to my calculator. I already have that last number there, so I'll just hit plus. Now, that didn't work on this calculator. It would on your Texas Instruments. I've got to hit answer, and then we're going to add 11 to it, and that tells us that the entire bottom side of that figure is 28.62. Okay, so 28.62 is this entire length from here to here, and that's what we needed right over here for base 2, everybody, 28.62. Whew, that's a mess. Now that we've got all that, I think the entire right-hand side is all known, so we're ready to go to our calculators. And for step 3, let's just figure it out. Area equals, and again, I'll do this with you guys. All right, so we've got a 0.5 out in front. That is getting multiplied by our height here, which was 21. And then in parentheses, we're doing the sum of our two bases, which is 11, plus that number we just came up with. So I'm going to do 11 plus, and I'll just hit my answer button right here. And that gets us our answer here, guys, as accurate as we possibly could. The directions here don't tell you where to round, so my general preference is to go 2 decimal places. I'm going to go 416.02 for this answer right here. 416.02. No units were given, so that's square units. All right, guys, that's a next level problem right there. So what we did in the last two, in number 16 and number 20, those are pretty tough ones. If you can understand those, you're in pretty good shape moving forward. All right, guys, good luck on the rest of that assignment. We need to get that done before we take our quiz here. And if you guys have any questions, let me know. Good luck.